Hey everybody, Mr. Kozad back again for another video lesson. This time our topic will be on the definition of the derivative. This is easily one of the marquee topics that calculus is all about, the derivative. So what we're going to look at today is we're going to look at how we're going to define a derivative, and we're going to look at what's called the formal definition of a derivative. So whether you have a printed notes page in front of you or not, use this lesson however best fits your needs. Feel free to fast forward, rewind, replay, rewatch, take a break, and come back later. This will be a little bit longer of a lesson, but it's got some really, really good stuff in here because, like I said, it's one of the key foundational, fundamental lessons of all the study of calculus. So the definition of a derivative. Okay. So here's how we're going to work up towards that definition. Okay, so if you were asked to do something like this, find the slope of the secant line. Okay, let's just there aren't actual points on there, but let's just make some up. Okay, so let's say that the points, these 2 point coordinates are 1, 3, and 4, 1. And you were asked to find the slope of the secant line. So here's the deal. You have to first remember what in the world is secant line. What does that mean? Okay. Well, a secant line is a line that passes through exactly 2 points on a curve. Okay, so it could look something like this. Notice how that line passes through those 2 points and those 2 points only. And we see that all lines, all linear functions, will have slopes. Okay, so in Algebra 1, you learned how to find the slope of a line that passes through 2 points. That formula was y2 minus y1 all over x2 minus x1. So if we plug and chug, we've got 1 minus 3 all over 4 minus 1, and we get negative 2 over 3. So we get the slope of the secant line to be negative 2/3. Okay? Well, what happens in calculus is we actually take these 2 points on a curve and we start to slide them closer and closer and closer together until there's actually right on top of each other. And we want to see what the slope of the line that passes through that point becomes. Okay, so here's how we're going to illustrate that. Okay, so let's fix 2 points on a blank curve like this. Okay, very similar to the one we just did. And let's call the coordinates of this first point x and f of x. This is just how we're going to find the coordinates of the points. It's just some x value, and we take that x value and we substitute it in some function to figure out what the y value is. Okay, and then this other point over here is going to be a second point that is a certain distance away from the first point. Okay, and let's actually call that distance h. Well, if the distance between those 2 points is h, think about the coordinates of this second point. The x coordinate is going to be x plus h. And then the y coordinate is we take function f and we plug x plus h in as our input there. So what we have here is we have the coordinates of 2 points. Okay, so then what we can do is if we use those 2 points to find our slope, okay, if we use those 2 points to find our slope. Remember, our slope formula is y2 minus y1, so that would be f of x plus h minus f of x, the difference of the y values, over the difference of the x values. So that would be x plus h minus x. Well, if I simplify that, here's what my slope ends up being. F of x plus h minus f of x all over h, because the x's on the bottom cancel out. So what happens here is as we slowly start to move these points closer and closer and closer together, what happens to h as I continue to move these points closer and closer and closer? Well, as we shrink h, we get points that are closer and closer and closer until h actually is going to equal 0. The distance between those points is 0. But if the distance between those points is 0, we have a problem. We can't actually use the slope formula anymore because we can't plug a 0 in for h. We can't have a 0 in the denominator of a fraction. So the way that calculus kind of gets around that is what we say is we say, all right, what happens if we take the limit as h gets closer and closer and closer to 0 of this slope equation that we just calculated? f of x plus h minus f of x all over h. Remember that evaluating a function at 0 and finding the limit is two different things. Okay, so this limit as h approaches 0 exists, even though the function can't have an h value that's 0 because you can't divide by 0. So what this is how we're going to find our derivative. Okay? So let's actually take that idea and talk about it a little bit further. So this is the formal definition of the derivative. It's that limit as h approaches 0 of f of x plus h minus f of x all over h. So again, what we're doing here is we're taking 2 points on a curve and we're getting them closer and closer and closer and closer together so that we actually get those points to be the same point. Okay, then that's not a secant line anymore. What this is going to produce for us is the slope of a tangent line. Okay, so if you imagine that same idea of a curve, as those points are closer and closer together, we have a tangent line. That's a bad picture, okay? We've got a tangent line that passes through exactly 1 point on that curve. So essentially what a derivative does is a derivative tells us, and you probably want to write this down, a derivative tells us the slope of a tangent line. The slope that passes through that curve at exactly 1 point, okay? So a couple things to talk about here with this definition of a derivative. Let's start here with this. The way you read this, if you were reading it out loud, is f prime of x. Prime notation is how we're going to define a derivative. So whenever you see this little symbol here, that's prime notation. It's f prime of x. That's the signal that that's the derivative. That's how we're going to notate that. Okay? And what this basically is f prime of x is a slope factory. What this does is if you can figure out what f prime of x is, you have a slope factory that you can take a bunch of different types of x values and you can plug them in this equation and you're going to end up getting the slope at that point. You're going to end up getting the slope at that point. So for example, f prime of x is going to equal the slope at x. The slope of the line, the tangent line, at point x, whatever x is going to be. And again, this is called the formal definition of the derivative. It's the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay? This is a lot of theory so far that we've talked about, sliding these points together and talking about the definition of a derivative. It's a lot of theory. If you need to go back and rewatch some of that or listen to the explanation again, please feel free to do so. But what we're going to do next is we're going to jump right into some problems and you're going to see how you're going to use this definition of the derivative. Okay, so here's the first problem we're going to talk about. It says, using the definition of the derivative, find the derivative of function f of x equals x squared minus 2. Now it says using the definition of the derivative. So that means we're going to take the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, here's what we do. Okay, to evaluate this limit, we are going to take function f and we're going to replace every x we see in function f with an x plus h. Okay, so that x that I see in function f, I'm going to replace that with x plus h, so it now becomes x plus h squared minus 2. And then I'm going to subtract f of x just how I see it as given. So minus x squared minus 2. Now I always put that in parentheses so that I remember to distribute the subtraction sign. I always usually put f of x in parentheses here to remind me to distribute the subtraction sign. So now once you get here, all you're doing from here is some algebra to clean this up. So this becomes the limit as h approaches 0. Let's go ahead and square x plus h. So when you square that, that becomes x squared plus 2xh plus h squared minus 2 minus x squared plus 2 after I distributed that negative sign. And don't forget that it's all still over h. Now from here, you're going to clean some things up. I see a minus 2 and a plus 2. Those cancel out. I see a positive x squared minus x squared, so those cancel each other out. So what I have left here is I have the limit as h approaches 0 of 2xh plus h squared on the top all over h. Now remember, I still can't use direct substitution to evaluate this limit because when I plug in 0 for h, down here I have a problem. You're not allowed to have a 0 in the denominator. But I'm sure some of you have already noticed what happens next is you have an h in all of these terms that can cancel out. So really what this becomes when I cancel out my h is this becomes the limit as h approaches 0 of 2x plus h. Now from here what you can do is now you can actually do direct substitution and evaluate the limit. You plug a 0 in for h and your derivative here is 2x. Now do not be surprised that you still have an x value in your derivative. Okay, don't be surprised by that. Okay, all right, so now what we're going to do is we're going to use that, okay, to kind of show you some ways that we can use it. So it says graph f of x equals x squared minus 2, which is the function we just worked with. Okay, so we're going to use that function. We're going to graph the original function, not the derivative. We're going to graph the original. Okay, so f of x equals x squared minus 2 is a parabola that has a vertex at 0, negative 2. I'm going to get a couple other points here. And I'm going to draw a rough sketch of that parabola, like so. Okay, so there is the original function. That's the original, okay? And what it's asking you to do is to find the slope at 1, 2, 3, 4, 5 different x values. Now, if you remember from a few slides ago, the derivative is like a slope factory. It produces slopes at any given x value. So to evaluate the slope at negative 2, what you're going to do is you're going to take the derivative of x, which we just solved in the last slide, was 2x. Remember that from the last thing we just did. So to find these individual slopes, you're going to take those x values and you're going to plug them in your derivative. So f prime of negative 2 is 2 times negative 2, which gives us negative 4. F prime of negative 1, I plug a negative 1 in for x, and I get f prime of negative 1 equals negative 2. You get the idea. We're going to go through and we're just going to plug in these x values that they specifically ask us for into our slope factory to see what the slopes equal. F prime of 0 equals 0. F prime of 1 will equal 2. And f prime of 2 equals 4. So again, what you see here is you see that this derivative just pumps out different slopes depending on what x value you're asking it for. Okay? Let's take a look at another one. So this one gets a little bit more interesting. Okay, so it says find the derivative of y equals negative x squared plus 3x. So again, our approach here, we're going to use the formal definition of the derivative. So we have the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so the very first step is the hardest one. You need to be really careful with this. This is where people make the biggest mistakes, is when they actually plug in x plus h here. So if I plug x plus h in for every x that I see in y, I get negative x plus h, the quantity squared, plus 3 times x plus h. There's my f of x plus h. Now I'm going to subtract f of x just how it showed up originally, which was x squared plus 3x, and that's all over h. Now from here, we just do some algebra to clean this up. So we have the limit as h approaches 0 of negative x squared plus 2xh plus h squared plus 3x plus 3h minus x squared minus 3x. Again, that's all over x. Oh shoot, I already missed something. I'm sure that some of you already noticed this, but when I rewrote, I missed a negative here. So fix that if you made that mistake, or you probably caught it because you're wise students. I've missed a negative originally. Okay, so just add that in because this should be plus x squared. Okay. All right, so now what we have happening here is we've got some things that cancel. Okay, I've got a negative x squared and a positive x squared. I have a positive 3x and a negative 3x that cancels out. So let's see what we have left over. So now we have the limit as h approaches 0 of negative 2xh minus h squared plus 3h all over h. Then you can probably see that we've got h's everywhere that can cancel out. So then if we rewrite what we have left over, now we have the limit as h approaches 0 of negative 2x minus h plus 3. And at this point, we can use direct substitution to evaluate this limit because there's no problems with plugging in a 0 at this point. So when I plug in a 0 for h, I end up getting negative 2x plus 3 left over. So my derivative here, f prime of x, equals negative 2x plus 3. Again, do not be surprised when you see an x in your derivative. Okay, that's not a problem. Okay, and remember that this derivative is just a slope factory, and we're going to practice that on the next slide. Okay, so here it says find the slope of f of x equals negative x squared plus 3x. This is the same function we just found the derivative of. So I already know that that derivative from the last slide was negative 2x plus 3. We already did that work. And this problem asks me to find the slope at these 3 points. So to do that, I take those points and I drop them into my slope factory, my derivative. So negative 2 times negative 1 plus 3 gets me 5. Then we plug in a 0 into our slope factory and we get a slope of 3. And we get plug a 2 into our slope factory and we get negative 4 plus 3 gives me negative 1. So once you find the derivative, finding the slope at each one of these points is super, super easy. Again, you just take those and plug them into the derivative, not the original function, but the derivative. Okay. Now this is the other type of problem that you could see in this lesson. Okay, you'll be asked to write an equation of the tangent line. Okay, equation of a tangent line of the function negative x squared plus 1 at the point x equals negative 1. Okay, so here's what we're going to do. We are going to start by finding the derivative. Okay, we're going to find the derivative. So to do that, we're going to take the limit as h, not x, as h approaches 0 of f of x plus h minus f of x all over h. Okay, so I'm going to move a little bit quicker through this derivative because we've practiced it a bunch. If you want to try finding the derivative yourself, you can go ahead and pause it here and then pick back up when you're done and check to see if you have the same thing that I have. But like I said, I'm going to go a little bit quicker through this because I've already kind of explained how to do this. Okay, so here we go. So the limit as h approaches 0, when I plug x plus h into f, that's negative x plus h squared plus 1 minus negative x squared plus 1 all over h. So I'm going to FOIL x plus h. That gives me negative x squared minus 2xh minus h squared plus 1 plus x squared minus 1 all over h. Then I see what cancels. I have a plus 1 and a minus 1. I have a negative x squared and a positive x squared. all cancel out. I'm going to go ahead and cancel the h's. I've got an h here, here, and here that cancels. So what I have left over here is I have the limit as h approaches 0 of negative 2x minus h. When I use direct substitution to evaluate that limit, I get that the derivative is negative 2x. Okay? All right, now here's how I use that. Okay, so it specifically wants to know the equation of the tangent line at x equals negative 1. At x equals negative 1. Okay, so what happens here is this is a parabola that has a vertex at 0, 1, and that opens down like this. So what this problem's asking you to do, it says when x equals negative 1, okay, when x equals negative 1, it wants to know what is the slope of that tangent line right there. Or I'm sorry, not just the slope, the equation of that tangent line. So the first thing I want to find is I want to find the slope when x is negative 1. So I want to find f prime of negative 1. So when I do that, I take negative 2 times negative 1, and I get positive 2 as my slope. Okay? Now the next thing that I want to do, okay, the second step here, is I want to find a point. Find a point on the original curve when x equals negative 1. So pay attention to this. This is kind of a weird step for people. If you want to find the point on the original curve when x equals negative 1, you're going to take that negative 1 and you're going to plug it into the original equation to find what the y value is when x equals negative 1. So that's going to be negative 1 squared plus 1. So when we do that, we get negative 1 squared is positive 1. Make that negative, it becomes negative 1. So negative 1 plus 1 gives me 0. So the point that I'm going to use here is negative 1, 0. Now when I take these two pieces and put them together, I can write an equation in what's called point-slope form. So that's going to be y minus 0 equals my slope, which I got from the derivative, 2 times x plus 1. And that, ladies and gentlemen, is the slope of the tangent line. So again, to explain kind of this process, I needed to do two things when you're asked to find the equation of the tangent line. You need to find, number one, you need to find the slope, and number two, you need to find the point that it passes through. So I did that in two parts, actually 3 parts. I found the derivative first, and then evaluated the derivative at negative 1, and then figured out what the function value was when x equals negative 1. Okay, that's a lot. If you need to go back and rewatch that, please do. Okay, don't be a hero. Don't try to pretend like you understand complicated calculus after just a few minutes of an example explained. Okay? All right, so I have another one that I'd like for you to try. Okay, I'd like you to try this on your own. It's the exact same directions as the last problem. Equation of tangent line is what we're looking for here. The function has changed, so you're going to have to find a new derivative, and the point has changed. We're going to plug in x equals negative 2. So remember, here's your 3 steps. The first thing you want to do is find f prime of x. Once you find f prime of x, you want to take 2 and plug that into the derivative that you found. So find f prime of 2. And then the third thing you're going to want to do is you want to figure out what is f of 2. What is the original function's value when x equals 2? And then the last thing you're going to do is write an equation in point-slope form. So give that a try and see what you can come up with. Pause it now, try it on your own, and then pick back up when you're done. Okay, hopefully you paused the video and you actually tried this. I'm going to show you my completed work so you can check to see if you got the same thing that I did. What I found is I got the equation to be y plus 12 equals negative 12 times x minus 2. So if you got the same thing, you're doing an awesome job. That's a great job. If you didn't get the same thing, start back with the derivative. Did you get negative 6 for your derivative? If not, I'm sorry, negative 6x. If you did not get negative 6x, go back and look at the work in purple to figure out where you made your mistake. If you did get that, did you get the specific slope when x equals 2 to be negative 12? Go back and check that. If you just had the slope right, but you had the point and point slope wrong, look to see, did you actually plug 2 back into the original function? Okay, some things for you to check. All right, the few other things that we're going to work on together. This is a really fun problem here, okay? This derivative is really spicy. I'm not going to lie to you. Okay, so let's jump right in. So we're going to take the limit as h approaches 0 of f of x plus h minus f of x all over h. Next step is to just plug everything in before we do any algebra. So it's going to be 2 times x plus h cubed minus 3 times x plus h plus 1 minus, put the whole thing in parentheses to remind yourself to distribute the negative. All that is over h. Now this, like I said, this is not super fun because we have to sometimes do some work that requires us to actually do some get some scratch paper out and try a few things. So you're going to have to do x plus h times x plus h times x plus h. Okay? Honestly, as a calculus student, you should be familiar with this and have done it before. You might not like it, but you should be familiar with it. Okay? So go ahead and take some time and try to multiply that out. I'm going to work through it as well, but I'm not going to explain the step-by-step on this because that's not really the purpose of this lesson. So we get x squared plus 2xh plus h squared times another x plus h. And when I do that, I get x cubed plus x squared h plus 2x squared h plus xh squared. Running out of room here. Luckily, I can just move stuff around. Plus xh squared plus h cubed. So when we combine our like terms there and go back to our original derivative, we've got the limit as h approaches 0 of 2 times x cubed plus 3 x squared h plus 3xh squared plus h cubed. Don't forget here, okay, that you still have the rest of the derivative to take care of. So that's minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1, as I'm running out of room, all over h. Okay, so if I distribute the times 2, I end up getting the limit as h approaches 0 of 2x cubed plus 6x squared h plus 6xh squared plus 2h cubed minus 3x minus 3h plus 1 minus 2x squared plus 3x minus 1, all over h. We are almost done, y'all. The hard part's over. Honestly, the hardest part was x plus h cubed. So now you see that you've got some things that are going to cancel here. Okay, so we've got a 2x squared. Well, let's do the 1. We got plus 1 minus 1 plus 3x minus 3x. And then I've got, let's see here. We've got, oh shoot, I forgot that this here is x cubed. Sorry, my mistake. So then the minus 2x cubed and the positive 2x cubed all cancel out. Okay, so we have everything left has an h in it as well, so we can cancel some h's. Okay, that makes this squared, that makes that to the first, that cancels this out. So here's what we're at. We've got the limit as h approaches 0 of 6x squared plus 6xh plus 2h minus 3. And now we can do direct substitution where we plug a 0 in for each h, and we end up getting 6x squared minus 3 as my derivative. Ooh, that's a good one. Okay, that's a really good one there. I hope that you probably picked on the mistake that I made earlier when I when I translated this, distributed the negative sign of 2x cubed. I, for some reason, just made it squared. So yeah, that was my mistake. Hopefully you probably caught that because you're smart kids. You probably caught that and fixed it. But again, this problem, the nice thing about these problems is they always simplify to be something pretty clean and easy. Okay? So here's another one for you to try. Same directions as the last one. You're going to find the derivative. Okay? So that's basically what you're going to do is you're going to find f prime of x by taking the limit as h approaches 0 of f of x plus h minus f of x all over h. So pause the video now and give that a try and pick back up when you get it. Okay, hopefully you tried this. If you had some problems or you're just powering through the video just to get it done, I'm going to show you my work. So here it comes. Here is what the first thing that I would check is, did you get negative 1 over x squared? Okay, that should be the derivative that you got. If you did not get that, let's go to the very top and look. Okay, this is a critical step right here. Check this part right here. Did you have 1 over x plus h minus 1 over x over h? Okay, if the answer is yes, then look at the next step. Did you combine those fractions on the top? Did you combine those fractions on the top into one fraction? Okay, just a real quick reminder, 1 over x plus h minus 1 over x. We multiply the first equation by x over x to get my common denominator. And then I multiply the second equation by x plus h over x plus h to get those denominators to be the same. So when you combine those, x minus h gives me negative h over x times x plus h. Okay? If you messed that step 2 up, you probably didn't subtract the fractions correctly. So then remember that dividing by h is the same as multiplying by 1 over h. And when I do that, I see my h's cancel. Okay, so what I'm left with is negative 1 over x times x plus h. And at this point, I can go ahead and do direct substitution. It's not a problem to plug a 0 in for h now because my denominator will not become 0. Okay, it becomes x squared. So that was a lot, okay? That was a lot. So switching gears to just take a little break for a minute, okay? To take a little break for a minute. Here is just a function, okay? And we were asked to just sketch the tangent line at these particular points. So for example, when x equals 3, we go over 1, 2, 3, we put a point there. And you want to draw a line that passes through that point and that point only, okay? This isn't super... it's not super easy to do, but that would be what the tangent line looks like there. So then we would see at x equals 1, okay, we see that the tangent line is actually horizontal, which is okay. And when x equals negative 1, we see that we have a slope that is negative. So this slide is just to practice a little bit seeing what tangent lines look like. Okay, I probably should have moved this up towards the beginning. But like I said, it was a nice little change of pace for you. Okay, so we actually only have one problem left, and it's very similar to what we've already done. Okay, the last problem I want you to try is here. Write the equation of the line tangent, okay, to f of x equals x cubed minus 2x squared minus 4x at the point x equals negative 1. But look here, this is an important distinction here. They actually give you the derivative. They give you the derivative. So go back and look at one of the previous examples where you had to write the equation of a tangent line. And remember that the steps you need to follow are, the first thing you need to do is find f prime of x, which they gave you already, so that's done. So the next thing we do is find f prime of negative 1, then find the function value when x is negative 1, so find f of negative 1, and then put it together to write your equation. So pause the video now, try this on your own. It should not take you nearly as long as the last few have because the derivative's already given to you. Okay, welcome back. Hopefully you worked on this. Here is what you should have. Okay, so they already give you the derivative. Okay, so finding the slope, you should have got the slope to be 3 because that's the slope of the tangent line at x equals -1. And then we plug -1 into function f, and we get the point that it passes through to be -1, 1. And then I take both of those concepts, the slope and the point, and I plug both of those into point slope form to find the equation of my tangent line at x equals 1 to be y minus 1 equals 3 times x plus 1. So hopefully you got that correct. Hopefully you picked up a few things in this lesson that were helpful for you. The best thing you can do is practice this. Again, formal definition of a derivative. If I go back, formal definition of the derivative, a couple more, is the limit as h approaches 0 of f of x plus h minus f of x all over h. Hope you enjoyed the video, and I'll see you next time.